to the 2011 Cannonball Olympics.
We are here today at the Losey Pool in Hyde Park. We are joined by Maria, Tanner, and John, the world-renowned cannonball champions.
Hi. Hi. What exactly is the key to the perfect cannonball? I've always thought it was the mass of the person's ego, but apparently I'm wrong.
No. It's all about physics.
Ugh. But I don't know anything about physics, and physics isn't even applicable in real life.
Are you nuts? Why? How do you think you're even sitting here? It's all about gravity, which brings me back to the Olympics. You see, the key to a perfect cannonball involves components of projectile motion.
Projectile motion. I know what that is, like when someone upchucks, right?
Letter A. That's what... if you must think of it that way. But let's look at how other projectiles work. We'll use Maria as our first example.
Oh, I got stuck. I was going to say, what was that? Jumping over.
As you can see, there is an X and Y component involved in the cannonballer's motion.
The alphabet starts with A and B, not X and Y, you idiot.
Listen, the X component is the horizontal motion, and the Y component is vertical motion.
But she's making a frowny face, not a line.
That's called a parabola. And that's what happens when horizontal and vertical motion happen at the same time. As the person falls, the horizontal velocity keeps her moving, which forms the frowny face.
I guess that makes sense. But how does that work?
Well, the horizontal motion is constant and can be found using the equation v equals d over t, where v equals velocity, d equals distance, and t equals time. The vertical velocity is constantly changing due to gravitational acceleration. To find the velocity at any point, you use the formula d equals vit plus 1/2 at squared, where d equals distance, vi equals initial velocity, t equals time, and a equals acceleration, which in this case is due to gravity.
But you don't know what the initial velocity is. So, ha!
Actually, I do. The initial velocity of a projectile at the top of the projectile is always 0. And the distance or height you achieve is a critical element to making a good splash.
And a big splash means a big score, which is what I, for one, want to see today.
Good point. Anyways, contestant number 2, are you ready to rumble?
And now for contestant number 3. He's a legend in the Pro Cannonballing League, having achieved the Guinness World Record for biggest splash. I heard he even outsplashed Moby Dick.
You gotta get over here. Ah! Oh, God!
Wow, that was incredible!
Get back up to the top because the buoyant force acting on him. Buoyant force equals rho vg, where rho boat equals the density of the fluid, v equals the volume of the fluid, and g equals the acceleration due to gravity, which is constant and equal to 9.81 meters per second squared.
Wow, I didn't know you knew anything.
Ouch!
Yeah, well, I bet you don't know why there's a big splash.
Of course I do. It's due to the Lecompton slooshing effect.
Funny, I never heard of that.
That's because you're an uneducated schmuck.
Or maybe because you're a dumb blonde. Unlike High Chancellor Finley, president of this current circuit.
I don't get it.
Anyway, the gravitational force of the person downward pushes the water upward because the person's mass causes the water to be displaced, since the person takes up the space where the water was.
Gravity is working against me.
I don't believe you. Liar!
The proof is in the pool. Jump in and find out.
I can't. I'll melt.
Water won't convert you into heat energy, I promise.
Hey! It looks like a wave pool. I want to go in.
I'm sure you do. But before you go in, you have to learn a few things about waves. We'll start out with, for starters, v equals f lambda, where v equals velocity, f equals frequency, you spelled it wrong, and lambda equals wavelength.
How would you know any of that? It's never the same.
Of course it's never the same, because the mass of each person is always going to be different, so the waves will have a different velocity, frequency, and wavelength.
But how would you know what the values are?
Well, you time the number of waves passing a certain point per second, and that's the frequency.
What about the wavelength?
Well, the wavelength is the distance between waves. So you simply measure that, and there you go. But if you notice, the farther the waves go, the smaller they get. The frequency increases, but the wavelength decreases.
Well, yeah, that's because they lose energy the farther they get from the point of origin.
And you know something else.
I'm on my way to winning a Nobel Prize.
Well, good luck with that. Well, it's been an exciting day here at the 2011 Cannonball Olympics. We thank you all for joining us here on Newton News on Channel 9.81.
I hope you all learned as much as I did today, and remember, physics is everywhere!
It's all here!
It's physics, yeah, yeah, yeah. It's physics, yeah, yeah, yeah. It's physics, yeah, 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 yeah. When you are falling down and you can't get off the ground, you wonder what it is that's keeping you this way. I say it's physics, specifically gravity. Yes, it's physics, CF equals mg. When you make a big splash, displacement is the key. The water is pushed out and falls back to the ground. I say it's physics, specifically gravity. It's physics, CF equals mg. It's physics,